Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Algebraic. That channel is specially created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. I wish to sincerely appreciate your steadfastness in staying true to us. Thanks for subscribing. Now, today we are looking at a very important topic in further mathematics really, and that is binomial expansion. What exactly is binomial expansion? Of course, we are going to start today. We can't by any means finish the entire concept of binomial expansion in a single video. So today we hope to look at the introduction of what binomial expansion is all about. Then two, we have to explain the concept of Pascal triangle, and we end the class with looking at how to solve simple binomial expansions using Pascal triangle. To start with, what is binomial expansion? As the name implies, binomial expansion. Binomial, bi means two basically in mathematics. The nomial means numerical values or otherwise. So binomial means you are dealing with two distinct values or quantities. Then expansion. As we know in elementary mathematics, when we use the word expansion, we are meant to open up a bracket. And the simplest power of opening up a bracket is power 2. So power 2, 3, and so on and so forth. So imagine the topic, two words now. We have binomial on one hand and expansion. It basically means you are trying to expand the bracket having traditionally two terms to as many powers as possible. That's just the simple layman explanation of the concept of binomial expansion. But mathematically, there is more to it. Now, to understand binomial expansion, we have to take a quick detour to understanding the concept of Pascal triangle. What is Pascal triangle? Pascal triangle is more or less a simple way of enumerating the coefficients of an expansion of binomials. So, to start with, let's first take a look at the Pascal triangle. Essentially, when you expand, let's say x plus y, these are the binomials. To start with power 0, to start with, you're going to have 1 here as your answer, because any value to the power of 0 is 1. So essentially, we have here 1. Now, if you have x power plus y to power 1, this is simply just 1x plus 1y. Don't forget, Pascal's triangle deals with the coefficients only really. So the coefficients here are 1 and then 1. I'm going to have at the end here 1 and then 1. So if I have power 2, x plus y to the power of 2, that's going to be x squared plus 2xy plus y. That is on expanding this bracket. Again, the coefficients will be 1, 2, and 1 here. So we're going to have at the end 1, 2, and then 1. If you go further to have x plus y to the power of 3, that gives us in expanding x cubed plus 3x squared y plus 3xy squared plus y cubed. Once again, we pick out the coefficients, and these are 1, 3, 3, and then 1. So you have what here? 1, 3, 3, and 1. Now you can see a pattern in the triangular structure I have on the right hand side, and that is what brings about the concept of Pascal's triangle. To start with, we can always see that there's 1 at the ends. We have 1 at the ends. 1, 1, 1, 1, 1, 1. Now the successive steps are gotten by simply adding the two numbers. So we have 1 plus 1, 2. Here, 1 plus 2, 3, 2 plus 1, 3. So that means if you continue on this side, we're going to have here, the next will be 1 here and 1 at the end. So 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. That's for power 4. We have x plus y, power 4. If you have x plus y to the power of 5, I'm going to have here 1 at the ends. So I'm going to have 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and so on and so forth. So as you can see, we're having a structure that looks more or less like a triangle of coefficients. and we have them in that form. Hence, this is called Pascal's triangle for determining strictly the coefficients of expansion. Now, if you look at another pattern apart from the coefficients now, if you look at the powers of the variables involved, as you can see, the very first variable here, in this case x, takes or assumes the largest power, which is 3. Then subsequently is decreasing. You can see x power 3, then x power 2, x power 1, then x power 0, it vanishes. On the other hand, the other guy here, the partner here, is increasing, vice versa. Y x is decreasing in power, y is increasing in power simultaneously. So here, y is power 0, here, power 1, power 2, and power 3. So these are the two things you have to look at: the coefficients of the expansion and the corresponding varying powers of the two values we are actually expanding. So this is the concept of Pascal's triangle. So if you have to get this easily now, and okay, let's say we have x plus y to the power of 6 now. That's simply going to be 1, 6, 15, 20, 15 again, 6, and then 1 at the end. So in expanding this, I'm going to have x power 6, that is 1 is the coefficient here, then plus 6, x power 5, then y power 1. At every point in time, the addition of the powers must give us the maximum index there. Then I move again. The next one is going to be 15 coefficients first, then x power 4, y power 2. As you can see, as x is decreasing, y is simultaneously increasing, such a way that the addition of the two powers must give us the 6. Then the next coefficient, 20, x power 3, y power 3. Then the next thing, 15, x power 2, y power 4. The next, 6, x power 1, y power 5. And then lastly, 1, y power 6. So this is the expansion of x plus y to the power of 6, which is quite more advanced compared to the elementary expansions you have in mathematics, whereby you're going to have x plus y, x plus y, x plus y, x plus y. That's quite cumbersome. This is a more mature and advanced way of expansion, courtesy of understanding the Pascal's triangle and the varying powers of the binomials. So this is the Pascal's triangle. Now we move on. Here we have to expand and simplify. That's our example. Expand and simplify. One we have 2x plus 3y to the power of 4. Okay, 2x plus 3y to the power of 4. So let's use the concept of Pascal's triangle here. So note there are two things we're looking at. First, the coefficients, and second, the varying powers of the expansion in the bracket. So we have here, to start with, we know the coefficients to be 1, 4, 6, 4, and 1, because we are dealing with power 4. This power 4 here. Power 0, power 1, power 2, power 3, this power 4. So you have 1, 4, 6, 4, 1. Those are the coefficients to start with. Then let's now affix the values here. So the first one, you're going to have 2x to the power of 4. Remember, the very first one takes the entire power, and subsequently it decreases, whereas the other guy increases. Then plus, here again I'm going to have 2x this time around, power 3, then 3y power 1, plus the 6 there. So we have again here 2x power 2, and of course 3y also power 2. Then we had 4 there, 2x power 1, and 3y power 3. Then lastly, we have 1, then 2y power 4. So if you look at that, coefficients 1, 4, 6, 4, 1. These are the coefficients 1, 4, 6, 4, 1. That's to start with. Therefore, the powers, as you can see here, the powers are, remember now we have 2x here, so the entire 2x stands for a single value. So we have 2x power 4, power 3, power 2, power 1, and vanishes completely. Whereas the other guy is 3y, power 0, power 1, power 2, power 3, and power 4. The next thing is now, we actually expanded now, let's simplify. So this is 2x power 4, that is 16x power 4 plus 4 times 2x power 3 is 8x power 3, then just 3y plus 6. These are 4x squared, then 9y squared. Therefore again, 2x, 3 cubed is 27y cubed. Then these are 16y 4. So these are the expansions. So going forward, we just open the bracket by multiplication. You can use our calculator there. So you have 4 by 8, that is 32. Then by 3, that is 96. So we've got 96 x cubed y plus, then get 649. We have 216. 216 x squared y squared. Then here 4, 2, 27. You've got again 216 x y cubed, and lastly 16y to the power of 4. So that essentially is the full expansion and simplification of the binomial there, 2x plus 3y all to the power of 4. Okay, let's take the next example. Here we got expand and simplify 3m minus 4n to the power of 5. The power of 5. So for the Pascal strand here, we've got our coefficients as 1, 5, 10, 10, 5, 1. That was from the Pascal triangle. So you have to take note of these coefficients. Hence, we go by having the first one 1, then 3m to the power of 5. Then you have plus, this time around 5, which is the next coefficient, then 3m reduces now in power 4. Then we have, don't forget, there's a minus there, I have to include minus there. Minus 4m to the power of 1. Then the next coefficient is 10. 10, then we have 3m reduces further, power 3, minus 4n, power 2. Then another 10, this time around 3m to the power of 2, minus 4n to the power of 3. Then 5 now, we have 3m to the power of 1 and minus 4n to the power of 4. Then lastly, just 1, then minus 4n to the power of 5. At this juncture, there's no more 3m to the power 0 here. So what we do here is to now simply open the bracket. 3 to the power of 5, that's 3 to the power of 5, then m goes to the power of 5. Then plus 5 is 3 to the power of 4, m to the power of 4. Of course, again, minus 4n. That's the second m. Then there we have 10, 3 to the power of 3, m power 3, minus 4 power 2, n power 2. Then 10, we have 3 squared, m squared. We've got minus 4 cube, n cube. Then the next time there, 5, 3, m minus 4 to the power of 4, n 4. We are just mainly dealing with indices here. Minus 4 over 5, n over 5. So those are the expansions. Now let's now get the numerical values. 2 to the power of 5, that's actually 2, 4, 3. We have 2, 4, 3, m over 5. That's the very first term. Now, 3 to the power of 4 is 81. times 5, then comes minus 4. That's minus 4 minus 1, 6, minus 1, 6, 2, 0. M power 4, and then n. Then here we have, so we have the 10 by the power is 27, that's 270 by 4, minus 4 squared is 16, that's 4, 3, 2, 0, m cubed, n squared. Then you have 9 here. 9 by 10 is 90 by minus 64. That gives us minus 5760 n squared n cubed. Then plus here 4 power 4 is 256 there. So you have 256 by 15, which is 5 times 3. So you have 3840 m n power 4. And lastly, we've got minus 4 to the power of 5, that is minus 1024 n power 5. So this is the full expansion and simplification of the problem 3n minus 4n to the power of 5 using the concept of Pascal's triangle. And I believe with that we have a good understanding of the concept of Pascal triangle, pretty much as I expect you to. So the class has been fun, and I believe you find it so as well here. So if you find the class quite interesting, which I believe and expect, I urge you to please subscribe, stay tuned, like, share, and don't forget to put on your button so that you'll be first to know when the next video shall be dropped, and whereby we are going deeper into the concept of binomial expansion proper. Thank you and stay blessed.